I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
The global bioeconomy has evolved from an ambitious vision into an urgent planetary necessity. Humanity stands at a crossroads, facing the triple crises of climate change, dwindling resources, and food insecurity. And biology may well be the new operating system for survival and growth. By 2050, the world's population will exceed 10 billion. Producing enough food, fuel, and materials will demand doing far more with far less. Less land, less water, and a fraction of the carbon footprint. Analysts predict that biological innovation could shape nearly half of global economic output and generate up to $4 trillion a year by 2030. Think about that. Biology influencing everything from energy and agriculture to medicine and manufacturing. According to McKinsey's BioRevolution study, bio-based solutions could replace as much as 60% of the world's physical inputs. But here's the catch. Discovery alone isn't enough. The biggest challenge is scaling innovation from the lab to real-world production. Bridging this valley of death between discovery and deployment is now the defining test of our time. So what's driving this next leap? It's the fusion of artificial intelligence, biotechnology, quantum computing, and automation, a convergence that is turning biology into an engineering discipline. Generative AI now helps scientists simulate and design biological systems in digital space before they're even grown in a lab. What once took years can now happen in weeks. Companies like Ginkgo Bioworks and Arzita are already using AI to create enzymes that digest plastics, synthesize biodegradable materials, and even produce new kinds of lubricants from plant sugars instead of petroleum. Meanwhile, China is emerging as a major force in this transformation. Through massive investments in national synthetic biology centers, companies like BGI Group and Zhongke Sengyu are combining AI with robotic biofoundries to design microbes that can produce everything from bio-based textiles to pharmaceuticals. China's biofoundry programs in Shenzhen and Tianjin are now among the most advanced on Earth, prototyping engineered cells at industrial scale with the precision of semiconductor fabs. Quantum computing adds another dimension to this revolution. For the first time, we can simulate the quantum mechanics of complex molecules, modeling how enzymes fold, how reactions occur, and how to optimize energy efficiency in biomanufacturing. Partnerships like IBM and Evonik's quantum chemistry collaboration are pushing industrial catalysis to new frontiers, while DeepMind's AlphaFold 3 has reshaped our understanding of proteins, helping design enzymes that capture carbon or cure disease. Automation is making all this scalable. Cloud-connected laboratories like Strateos and Riffian run thousands of experiments remotely, operated by AI and robotics. The result is a feedback loop of continuous learning. AI designs, automation executes, and quantum models refine the next generation of biological solutions. Together, these converging tools are transforming biology into something programmable, predictable, and profoundly powerful. To truly accelerate the bioeconomy, the world must build a connected ecosystem where discovery, regulation, and commercialization move in sync. Governments, investors, and innovators are forming new alliances to close the gap between science and scale. The EU's Circular Bio-Based Europe initiative has already poured over €1 billion into turning crop residues into bioplastics in sustainable aviation fuel. In the United States, the Department of Energy's Bioenergy Technologies Office and partners like LanzaJet are demonstrating how biofuels could replace 10% of global jet fuel by 2035. China, meanwhile, is taking a coordinated national approach through its 14th five-year plan for bioeconomy development. Its biomanufacturing clusters in Tianjin and Shanghai link state-owned enterprises, private firms like Wuxi AppTech, and startups into one seamless chain. from genome design to industrial-scale fermentation. It's a model of top-down efficiency that's rapidly turning China into a bioindustrial powerhouse. Regulatory innovation is also reshaping the landscape. The US FDA's biotech pilot program has slashed approval times for bio-based materials by 40%. Singapore has gone further, establishing sandbox environments for testing vertical farms, biofertilizers, and lab-grown foods under real conditions. Education is another cornerstone. Universities like MIT and Wageningen now offer bioeconomy MBAs, blending biotechnology with data science and policy. Germany's bioeconomy cluster is training the technicians who will operate AI-guided biomanufacturing plants, addressing a skills gap expected to reach 1.5 million jobs globally by 2030. Even infrastructure is evolving. Cloud-linked bioreactors from platforms like Culture Biosciences now let researchers conduct experiments remotely. Startups like MicaWorks are using this model to scale mushroom-based leather worldwide, a symbol of how decentralized manufacturing can rival the efficiency of traditional industries. Across the Asia-Pacific, entire nations are embracing the bioacceleration. Singapore has turned itself into a living biolab where R&D, pilot facilities, and production coexist in one ecosystem, cutting product timelines almost in half. Australia is converting sugarcane waste into bioplastics and sustainable fuels, while developing modular AI-driven biofoundries. New Zealand is blending indigenous ecological wisdom with advanced biotechnology to create circular forest biorefineries and precision-fermented dairy alternatives. And China, with industrial-scale fermentation plants and state-led coordination, is redefining how fast the bioeconomy can scale when science, industry, and policy move together. Public-private partnerships are the connective tissue of this transformation. The U.S. Inflation Reduction Act and the EU's bioeconomy strategy offered tax incentives for sustainable fuels and circular materials. Programs like BioMade link startups like Solugen with global manufacturers like Cargill to co-develop carbon-negative chemicals. China's Synthetic Biology 25 megaproject goes a step further, ensuring that new research in bio-based chemicals directly feeds into full-scale industrial production, from textiles to renewable polymers. Around the world, open innovation networks are emerging. A global bioeconomy gateway could someday link researchers, investors, and industries, where a startup in Sao Paulo could license CRISPR IP from MIT, pilot its fermentation with ADM, and partner with Unilever through a single digital platform. Singapore's Agri-Food Tech Accelerator already demonstrates this future, cutting commercialization times for startups by nearly half. And we're seeing tangible impact today. Companies like Neste and LanzaJet are converting waste CO2 and forestry residues into clean jet fuel, while in China, Sinopec is scaling the same technology using biomass and used cooking oil. CRISPR-edited crops from Pairwise and Benson Hill are reducing food waste and water use, while Chinese labs are advancing gene-edited rice and wheat for higher yield and disease resistance. Meanwhile, LanzaTech's carbon recycling technology, first developed in the U.S., now powers ethanol plants in China's steel industry, turning industrial emissions into sustainable fuels and fabrics. All of this points toward one reality. The bioeconomy is no longer a niche. It's becoming the foundation of a new industrial revolution. The tools are ready. AI, quantum computing, automation, and synthetic biology have made biology designable, measurable, and manufacturable. The next step is synergy, aligning policy ambition with industrial collaboration to move faster from pilot to global scale. This transformation crosses borders and sectors. It's rewriting the rules of economics, from extractive growth to regenerative prosperity. By placing biology at the center of production, we can create a circular system that restores ecosystems while driving human advancement. The race is no longer about who invents first, but who scales fastest. And the nations and industries that master this integration Whether through the open innovation of the West, the coordinated scale of China, or the adaptive efficiency of Asia-Pacific, will define the next century. Not through fossil fuels, not through silicon, but through life itself, engineered, intelligent, and regenerative. Thanks for watching. Subscribe, follow, or visit IDSTH.com for more cutting-edge defense and tech insights. See you in the next one.